Welcome to yet another video uh, on Java and related technologies. So today's topic is about JUnit. If you have done a development and you're in the IT field for a certain years, right? You must have definitely heard of JUnit. Okay, so it's a unit testing framework which is used for testing your code, whatever you write. So it's written in the development phase, so that whatever code you write, whatever component you write, whatever the layer you write, you test it. Okay, and there is a certain criteria or certain, I would say, uh, uh, a coverage which has to be taken care. Like, certain companies have a restriction of, or a mandate for 80% or 90% of the code coverage should happen. But ideally, like, it's not very mandatory, but ideally, like, it's a standard where minimum 80% of that particular code, whatever you have written inside the method or whatever the code you have written, right, it should be able to be testable. So there are when it comes to, like, integrating and then testing, right? So basically, we make use of JUnit framework. Okay, so let's look into it. And if you also, like, it happens to be attending any interview also, right? So basically, Java, Spring Boot, microservices, this is one of the topic which uh, the interviewer is always looking out for. Like, uh, the development is done, right? What people are doing when it comes to unit testing. Because if you have heard of TDD, right, test driven development, where you instead of writing the code, right, you first write your test cases, you test it, and then you actually write your code, right? So that's the approach. So basically, it's quite mandatory to, for a developer, for a senior lead or a senior developer, right? So if you are attending an interview, or if you are seeking for that role, this is quite important, that whatever piece of code you are writing, it should be tested. Let's look into the agendas. So in today we are going to cover up what exactly is unit test, right? And why do we need to write this particular unit test cases, right? And there is a principle called first FIRST principle. So we are going to look onto each of this particular topic. So let's look at the very first topic. So what is unit testing? So as explained, like earlier bit, I gave a glimpse of like what exactly unit testing is about. So it's a small part of code what we have written, that it should be tested as part in the development phase, right? So any developer, any person who is going to do the development, that particular piece of code, whatever he has written, has to be thoroughly tested with all scenarios. Okay, so with like, there are framework, as I said, so which like for Java, like when it comes to web development, as I said, we have a Spring framework, right? Spring Cloud integration, right? Similarly, for testing, we have this JUnit. There are different versions, like JUnit 4, JUnit 5, like there have been different versions, but latestly, like what we are using is JUnit 5. Okay, and there are certain dependencies and certain layers when you try to test, like it's test controller, service, repository, right? So basically, when you're trying to test a certain piece of code where there is an involvement of certain dependency, or certain data has to be get from certain an API, right? We should be able to test it with the fake object, that is using the Mockito, Power Mockito, or a Spy, right? So because that's the way how we test the dependencies when it comes to mocking it and then testing it. Now, when you write a test cases, you have to test both scenarios, right? It's not only the positive use cases. You have to write a code to break that and see, like if the when you're passing the negative scenarios, like null, minus, or some exception, right? You need to take the input, whatever might be the input, and then you your code should behave properly, and then it should execute without any hindrance, right? So you should write like a single method, whatever we have written, or a piece of code we've written, that can have multiple I mean, we can write for, yeah, for one code, right? We can write more than one unit test cases. Okay, so it may happen that there may be a scenario, just an example, like for a positive use case, for a negative use case, or the number greater than or number less than, whatever scenarios it is, we can test it. Okay, so it should be tested with all the relevant code whatever you have written. And as I explained, 80% of your code is mandatory to be tested, because that's quite standard in any organization. If it is better if you write it more than that, but minimum is what, 80%. So generally, like when you have a test case, unit test case is written, right? Basically the structure is like, you have a class, you have a methods, and inside that method you have a code, right? And inside that method, whatever we have written, we wanted to get it tested. Basically, like the new method you have written, and you wanted to test and see, like how it behaves. So in that case, we make use of JUnit framework. Okay, now if the unit test case, what happens is that when you try to run that particular test case, so in test also, unit testing also, what there is a provision to run those particular test cases one by one, and also there is a test suite which is called, where you can run all the test cases one by one. Okay, so there are certain prerequisite method, like setup method and other methods, which act as an prerequisite, and then it will be required for as an initialization for another methods. So you can test all, like when you test any scenario, and if it is succeeded, you'll get a green mark, right? So it will be marked as green, so you'll get to know that this particular test case is working properly, and the code whatever he has written is covered, and then every piece of code is working as expected. Okay, and when it is marked as red, it means that the code whatever you have written, right, it is not working as expected, and whatever input it has been taken, it is some way not working as expected. So you need to fix that thing. Okay, so let's jump into the example. So here, if you can see, I've written a code. There is a class called calculator. Now under that, let's say you wanted to test a method which says that multiply number. So I have two inputs. One is number and one is number two, right? So I have to return like the multiplication of that, right? So ideally, this is code. If you see the class, method, and then the code, right? Whatever we have written. Now we have to test each line of this code to for a certain scenarios. Now, if you see, there is a unit test case written over here. So basically, when you're writing any test cases, right, that particular method, whatever you write, right, it has to be annotated with @test. We'll look into more detail on that part, but this is just for an information. And also, when you are writing any test cases, your method should indicate that what test cases you are trying to run and what for what scenario. Okay, if you see here, like I've written that particular void test multiply number. So I'm going to test which method. I'm going to test multiply numbers, right? This method. Now I've written here as a different input provider. So what happens is that you may pass some, let's say if you see in this particular line where it says result number, right, and you are passed 2 and 3, right? So ideally, like what input you are passing. Let's say you're passing a scenario, a positive integer, a negative integer, or null, whatever use case. So you can actually write that, and then like what kind of scenario it is, you should name that, so that easily who is going to see it, right, and who is going to, let's say at the later part of the development, you need to modify that particular code. So he will be able to easily identify which code base I need to touch, and then modify it, right? So if you see, the first, it is arranged in three sections. First is like it's kind of prerequisite, like if you have to first arrange your things, so that there are all prerequisite things are there. Then you have to do, you have to call the actual methods, and then you have to check, like the result, how it is it what the expected result, what it is coming, and what we intended for. Okay, so arrange, act, and assert, right? So basically arrange is something where we initialize it and then we create an instance and then we do that. Now in act, right, you call that particular actual method, so you pass that particular method with that particular variables or input, and then you get the output in this particular result number. Now ultimately the main reason for writing unit test case is ultimately to decide whatever code we have written inside this particular multiply number, it is working expected or not. Okay, so when we assert this and then we compare this particular result with like 6 with the result number, we ultimately get that particular that it's a true, right? So it will mark it as green, it will be running successfully. Now the similar way we can write n number of methods over here for the same set of methods, same piece of code to test with minus numbers. Let's say you write it with zero numbers, like you try it with any other different scenarios to understand that it is working as expected or not. Okay, I hope you got this particular example. uh, why do we need to write unit test cases? So what is the need actually, why do we need to write it, like we'll discuss about that part. The reason for writing the unit test cases is that first of all, like it should work for the code whatever we have written, right? So what happens is that the new code has been written, you wanted to understand that you need to make sure that whatever you have written is correct, and then the test cases are passing on it, right? So it should work on the code whatever you have written. Now uh, that when you write or test any method or any piece of code, there are different scenarios, there are different inputs, right? So you should be able to the code should be working as expected and it should behave as expected, whether you're passing a valid input, whether you're passing an invalid input. So you should not, the code should not break. Okay, and ultimately, like, it should be producing the desired result. Now what happens is that the third point is like uh, as the code progresses, like, and multiple developer works on it, and like as the code grows old, right? So there are a number of features are introduced, new code are added to it, like certain implementations are done and certain code changes are done according to the logic or the business logic, right? So what happened is that from the code whatever it was earlier written, and like with the, let's say you have done enhancement or some changes in the code, right? Your code should work with the existing I mean the new logic, and also you need to make sure that you uh, uh, modify or make that particular wherever this particular piece of code is being used up, that particular test cases whatever it was written, it should be working as expected, it should not break the existing code, right? So let's say you have written some piece of code in the existing method, so it should not happen that your code is written right, and but your test cases are not working. You need to modify that, you need to make sure that that particular piece of code is also fixed up, right? So many times it happens you fix the development code, you forget about the JUnit test case whatever it is, but when it comes to deployment, ultimately, like the Sonar or like Jenkins, right, it will not allow you to build that until the all test cases are 80% coverage or more than that, and then there are some failures in it, right? So you need to fix that thing. Now there is a, when you write a code, right, overall to test a certain module or an application, there is a regression test, and so that any new piece of code that has been written in a certain module, a certain piece of code, it should not impact the whole application or certain different area, right? So regression test is done in that use case. Also your test case should be able to stand that, and then it should be tested, verified, and then it should be able to work as expected. uh, this is the the reason why do we normally uh, write like why do we need to write the test cases. Okay, hope you got this particular point. Now let's look at the next topic, that is first principle. So by looking at this particular what I've written here, right, you are able to understand, but we'll discuss with each of this. So there is a principle which when it comes to JUnit, right? So it should satisfy all these particular like solid principles, right? When you're designing a code or when you're designing a class, right, it should follow all these principles, right? So similarly, like when it comes to JUnit, right? So the very first F it stands for, right? It should be running very fast, right? So it should be able to run very quickly. So because as what happens is that when you write a code, right, and basically when it comes to actual calling the API or a certain call, like there might be possibility of little bit delay, but when it comes to writing test cases, right, so it should be really quick. And maybe like you're testing certain very big object as well, but still it has to be very quick, and you should be able to quickly run that. Okay. Secondly, whatever test cases you are writing, let's say you for a certain piece of code you are writing 10 test unit test cases. So nine of them should be dependent on it, right? So it should be each test cases should be written for a certain use case and certain this. It should not interfere with another method or like similar, right? So it should be doing each test cases should be written for their own purpose, right? uh, R. So if it is R is something which is it says that repeatable. So whatever the test cases you have written, right? No matter you run on what machine, no matter on which environment you run it, run it for once, you run it 100 times, it should produce the same result. Okay, it should not happen that the first use case it should run, and then the same test case you are running today, and then the same test case without any more code modification you're trying to run tomorrow. It is not going to work, right? So that should not be the case, right? You run it n number of times, your code should behave exactly what it is written for, right? And it should be working as expected. Self-validating. So what happens is that when you write and run this particular test cases, ultimately like you get an result, right? That particular result it validates, right, whether the test cases has run successfully, or it will be marked as green. If it is failed, it is marked as red. So right, so automatically that result will be validated. So it is the unit testing, it will validate itself, right? So it doesn't need to manually write something to tweak that to make it successful, because that will not make sense, right? Your code should actually run and then test it. Now thoroughly and timely tested means that whether it's like your happy path or your negative path, all kind of scenarios, whatever relevant to that particular code module or features, right, it should be able to test it with all scenarios, so that it doesn't miss out any use cases or any features, right? So you have tested in all means, so that you are confident that whatever input is written, like whatever code it is being provided, right, input is provided to it, it will run successfully, or it will be able to handle the scenarios, right? So that's it about like the first principle.